Alright, welcome. Today we're doing problem 29 from chapter 15. And this drawing refers to 1 mole of a monatomic ideal gas. Shows a process that has 4 steps, 2 isobaric, 2 isochoric. Complete this table by calculating delta U, change internal energy, work, and heat. Include the signs. For each of the 4 steps, I also added in this total because that's what we're here for. That's why we care about these heat engines. So let's start the work. So it starts off. We'll just go move it up a little bit. Just go start off A to B. So that's right there, that little guy right there. So since they gave us the temperatures, the internal energy should be pretty easy to calculate. That's 3/2 nRT. They also gave us the moles, 1 mole of a monoatomic ideal gas. R is 8.31 joules per mole times Kelvin. And the change in temperature, we're going from A, 400, to B, 800. So final minus initial, that's 400 Kelvin. If you multiply those together, I have it. It is 4,986 joules. There we go. Circle that. Put it in the table later. So then, since they gave us that it is an isobaric process, no change in pressure, so we can find the work. The work, because of our sign convention, is going to be negative P times change in V. And if we substitute this in with the other half of the ideal gas law, as we did up here, we could easily have 3/2 PV. So we'll just go a negative NR delta T. So negative 1 mole, 8.31 joules per mole times Kelvin. Change in temperature, we already know, it's 400 Kelvin. So, work for this one is a negative 3,324 joules. And obviously it's negative because the gas is expanding, it's increasing in volume. So work is being done by the gas on the environment. And now the easiest one of the 3, since change in internal energy equals work plus Q, we have U and W. So if we go U minus W equals Q, U is 4,000, and we're going to minus a negative, so that's going to be a plus. It's going to be addition, and that is 8,310. So we have all the variables for the first process, A to B, 4986. Yep. 3324 and 8310. Cool. Come back to that. Now, simply move on to B to C. Go chronological order. Now there's a little freebie in B to C. Since the volume is not changing, it's an isochoric process, The only way a gas can do work is if it expands and there's no area under the little line there. So we know that work, you see that? No. Work equals 0. Easy. Then we can go on, we can either find Q using an equation, or we can find delta U. I will go with delta U, just like the above equation, equals 3/2 nR delta T. Delta U equals 3/2 1 mole times 8.31 joules over moles times Kelvin. And this time the change in temperature, since we are going from B to C, final minus initial, it's going to be a negative 400 Kelvin. This time delta U is going to give us a negative 4986 joules. And then we'll just simply do delta U equals work plus the heat. So delta U, my mind just blanked. What were we finding? Oh, that's 0. So delta U equals Q. So Q is the same as the change in internal energy. So we'll just put those values on our table. Work is 0. This is Q, negative 4986, and so is the change in internal energy.